Hey guys, welcome back to my YouTube channel. So today's video is also a requested one, and it's on alcohols and hydrolysis again of esters. So when it comes to alcohols, there's primary, secondary, and tertiary ones. The tertiary alcohols cannot be oxidized, but the primary and the secondary can. The primary ones get oxidized to aldehydes and the secondary get oxidized to ketones. And right now what I'm doing is just drawing you guys a structure of a tertiary alcohol. Basically, it's an alcohol or a carbon basically that's connected to 3 other carbons and a hydroxyl group, which is an alcohol, which is the OH. Now this is what a primary alcohol looks like. It's a carbon that's connected to the hydroxyl group and only one other carbon. And for the secondary alcohol, it's going to be the same thing, but this time it's connected to 2 other carbons, hence secondary. So here I have these 2 examples. You have propan 1-ol and propan 2-ol. Now if you oxidize it, like we said, you're going to have, for the primary one, you're going to have an aldehyde, which is propanal. And for the ketone, you're going to have propanone. That's the suffix, the end name. So of course propan 2-ol showing that the OH is in the second carbon, or is connected to the second carbon. Now oxidation is not just the loss of electrons, it's also the loss of hydrogen or the gain of oxygen. So pay attention to that. Now you can go and online and find videos on the mechanism on how the alcohol would be oxidized to for example propanal or propan 2-ol, and if you want I can do a video on it, or you can just search it up yourself. So now on to the question. So this question is talking about which compound would produce a carboxylic acid and a ketone when treated with hot concentrated acidified potassium manganate 7. So I'm going to draw it out for you guys here. We have these skeletal formulas, and of course with every curve there's going to be a carbon present. And don't forget about the hydrogens, I'm just not drawing them in right now. So I'm going to place in all the carbons, and I'm going to tell you, when using hot concentrated acidic potassium manganate, the double bond would be broken in half, and you're going to have oxygens on each end. So we're going to do that for the first one, and you're going to realize that it works for all 1, 2, and 3 will be correct, and the answer would be A. But let's try it out first. So I'm going to just draw it out here. And what you're going to get a ketone and an aldehyde. But there's something that I didn't tell you about aldehydes, and that is it can be further oxidized into a carboxylic acid, hence giving us what the question asked, a ketone and a carboxylic acid. Now the ketone again is connected to 2 carbons, right? And it has a double bond oxygen. So that's the one on the left hand side. And the one on the right hand side is the aldehyde, which is connected to a hydrogen and the double bond O, and of course just one other carbon. The carbon is connected to just one other carbon. And if you continue doing this for 2 and 3, you're going to realize that it's exactly the same. And so that is it. Even when it comes to the pentagon in number 2, that would be where the ketone is, because the carbon with the double bond O is connected to 2 other carbons. And so yeah, that is the ketone. The other part would be the aldehyde, and which again would be further oxidized to the carboxylic acid, and hence why 1, 2, and 3 are all correct. And so A is your answer.